Alright, so to continue my little series of lab equipment calibration, I'm going to calibrate this BK Precision 2706A multimeter. Now unfortunately, this thing, while it does have adjustment pots on its PCB, I can't find any data or calibration procedures anywhere for this thing, so we're going to have to guess. Now fortunately, I know a little trick that can kind of help you figure out which pot adjusts what without actually disturbing the pot in the process. So I'll show you that in a second, but first let's, for fun, take this thing apart and look at its internals. Alright, so here's the BK Precision 2706A. It's just off by a little bit, so let's go and calibrate it. The annoying thing about this one is that you have to remove the screws in order to access the battery compartment. That's really annoying, and they're not even metal insert ones, they're the stupid plastic ones, you know, the self-tappers. Oh well. Oh, no, I must apologize. These felt like self-tappers, but no, they are real metal inserts. So, thank you very much, BK Precision. I like that. Another couple cool things about this design. This back panel here, you may notice the screws are still in there, because if you close the little stand here, the edges block the screw holes. So you can just close it like that, snaps in, and the screws don't fall out. Very nice. This little shield just presses into place there, and there's a little spring there. You've got one PTC, and that's about it when it comes to protection, really. Yep, that's about it. So anyways, here's the battery, of course. You got the beeper just kind of attached here. You got your crystal. Here you've got a Sina Wealth SH7108F, which apparently is a 32-bit RISC microcomputer. If you look that up on one of the datasheet lookup engines. And this is just a 74HC14D hex inverting Schmidt trigger. This will probably be for, I don't know, I guess the frequency counter. This thing has a little frequency measurement utility, a bunch of coupling capacitors, and not much else. I noticed that there's one little trim pot here that might be for the frequency. I'm not sure. And there's two down here. I'm betting that one is AC volts and one is DC volts. We'll have to figure out which is which. But anyways, let's take some more screws out and just check out the other side for fun. And nothing interesting here. You just got your switches here, AC-DC switch, LCD module with nothing interesting underneath. And yeah, that's about it. I think there might be a very thin layer of gold on there. It's hard to tell. But anyways, that's about it for this one. So on its ohms range and pretty much all the other ranges, it draws about 1.6 milliamps. Of course, out of a 9-volt battery, so it's using quite a bit more power than, of course, this thing. But it's still acceptable. I tried measuring a resistor, but it jumped up to only 1.7 milliamps, so not much of a change. Oh, and as you'd expect, when it's off, this thing uses no power at all because the range switch just interrupts power. Right, I think I figured out that this one here is the adjustment to use. And the way I figured that out is, well, I used my little can of, duster, turn it upside down to use it as a freezer spray, and froze that thing a little bit to see if the reading changed. And if I freeze these two down here, nothing happens. If I freeze this one, a lot changes, so let me show you. Alright, I'm going to just freeze that just a tiny little bit, just a little spurt. Hold on a sec. See? Huge change. Didn't like that. But it eventually settles back to its original reading. So I think if I tweak that one just a hair, then we should be in business. Warm that one up to ambient. My finger here. Yep. So let's try that one. Alright, so I tweaked it just a hair, And it seems to be perfect. Let's check the other ranges, or the other functions. Alright, here we are on the 1 milliamp test. 200 milliamp range, it is spot on. 20 milliamps, spot on. 2 milliamps, up just a hair off. Alright, here we are on the 1 milliamp test. 200 milliamp range, it is spot on. 20 milliamps, spot on. 2 milliamps, up just a hair off. Alright, well, the milliamp range, or sorry, the 2 milliamp range, I can't get it just right. These two don't really seem to do anything. This one does adjust it, however it also screws up the voltage one, so I think I'll live with that. Unfortunately for the ohms range, I also can't seem to change the calibration. So, I have no idea what these two are, maybe they're for the capacitance and the frequency. Or maybe the HFE. We'll see. But anyways, I'll consider this calibrated. For now, at least, to whatever I can accomplish. Calibrating this thing is going to be a bit more difficult, but I can at least get it to within what this thing can measure, I think. Alright, so now that I've calibrated this thing, I can use it to calibrate this power supply. Now, unfortunately, or fortunately, depending on how optimistic you're feeling today, this thing has a much higher capability for precision than this thing has, and also a higher resolution than this thing has, at least on most of its ranges. So I can't get it spot on, but you know, for me, for a lab such as this, which I'm not doing very high precision things, it'll be perfectly adequate. And if I ever need to get a higher precision, then I can probably borrow someone's multimeter or send it off to a cal lab. But anyways, that's the subject for another video. I'll end this one here. So thanks for watching, and hope you liked the video. See you next time.